So the next law I want to discuss, going along the theme of does order matter, is the associative law. An informal, quick way that we could summarize this law is, are we allowed to move brackets within an expression only containing the operation that we're interested in? So here we would be looking at whether AB can be performed first and then apply the operation with C as compared to BC first and then A. So does it matter if the BC is first as compared to the AB combination first? If it doesn't matter, we say that our operation is associative and we are allowed to move the brackets. Let's take this example into our happy face meets table and see what happens. Okay, so the associative property is not quite as nice as the other properties, like whether a set is closed or whether a set is commutative, in that I can't really look at the table and decide whether an operation is associative or not right away. There's a bit of testing that needs to be done. And in order to kind of do this testing comfortably, I'm going to label my happy with an H. It's a little bit hard to make that happy face every time. And unhappy will be a U, and surprised will be an S. Okay, so here we would have to test out the equation from above. Let's first remind ourselves what that equation is. So we'd have to do A combined with B combined with C in a different order. First combine the A and the B, and then combine the B and the C in comparison. We would like to know if these are the same. Now, notice I dropped writing meets between the A and the B. I could write meets everywhere here. Meets there, and meets there. It's just a lot more convenient to drop writing that operation. We can get away with that in the context of this question, because in this question, the only operation we have is meets. Mathematicians have done something similar with multiplication when they're writing out expressions. We tend not to write multiply when we write 2 times A, because it's just more convenient. It makes our expressions look a lot nicer if we don't have to write the multiplication symbol between those two numbers or elements of our set. Okay, so back to this topic. We want to know if this equation that we just wrote down is always true. Let's try some examples. So if we first try, let's say, happy, unhappy, and surprised. Happy, unhappy, and surprised. So first we'll combine the happy, unhappy, and then we'll compare that. We'll see if we get the same thing as compared to combining the unhappy and surprised first. So happy, unhappy gives you surprised. Surprised and surprised gives you surprised. Let's look at the other side. Unhappy and surprised give you unhappy. Happy and unhappy give you surprised. So notice this worked out. We did it in 2 different ways, and we got surprised on both sides of the equation. For this example that we randomly picked, we were allowed to move brackets. But this doesn't mean that we can always move brackets. Let's try another example. So if we go back to the start here, let's try happy combined with happy and then combined with unhappy. Okay, so this time happy and happy make happy, and if we combine that with unhappy, and then happy and unhappy make surprised. On the other hand, happy and unhappy make surprised, so you have happy combined with surprised, and then finally when happy meets surprised, that person becomes happy. So on one hand we got surprised, on the other hand we got happy. These two expressions are not equal. We have a counterexample that shows that meets is not associative, so the answer to this question is no. Let's consider some examples with the associative law and the set of real numbers. So is addition associative? This question is asking, if we have the expression a plus b plus c, does it matter how we bracket it? Or are we allowed to move the brackets? Let's say they start on the a and the b. Can we shift those brackets over to the b plus c? And the answer to this question is yes. You can picture, let's say you have 3 piles of objects in front of you. If you combine the first two and then you combine the third pile, you get the same result as if you combine the second 2 piles and then you combine the first one. Now that certainly makes sense with integers. It's a little bit of a stretch to stretch that out to real numbers, but we do say that this is true by definition. Is subtraction associative? Well, let's try this one out. So if we take, let's say, 1 minus 1 minus 1, and we perform this in 2 different ways. 1 minus 1 is 0, and then carrying the minus 1, we get negative 1. What if we do this with the brackets on the other subtraction symbol? So 1 minus 1 that came second, and then we'll write the 1 minus in front of that. So in this case, we get 1 minus 0, and we get positive 1. These two expressions are not the same, so we say that it's not associative. However, it was associative for addition. Let's move on to multiplication and division. So is multiplication associative? This is very similar to how we talked about for addition. If we have A, B, and C, and we're combining those, and we want to compare combining the A and the B first compared to combining the B and the C first. This is absolutely true. You can always shift the brackets among an expression that has 2 multiplication symbols. And again, this is true by definition. Is division associative? So after thinking about a few examples, you'll probably be able to come up with a way that shows that you are not allowed to move the brackets among a division expression. Let's try 1 divided by 1, and then all of that divided by 2. So if we were to evaluate this, first we would do the 1 divided by 1, and we would get 1 divided by 2. The result of that is 1/2. But if we try this the other way around, if we do 1 divided by the result of 1 divided by 2, so notice we're doing the second division first, this time we get 1 divided by 1/2. 1 divides up into 2 groups when we divide by half, when each group is 1/2, and you start with 1 you get 2. These two numbers are not the same, which shows that it's not associative for division. However, for multiplication, we can say yes. So a quick summary of this idea explains why sometimes we don't write brackets, and sometimes we do write brackets. In parts A and C above, for addition and multiplication, we don't even really need to write brackets. Sometimes we write those brackets anyway, just for an emphasis on maybe the AB part is important to look at, or maybe the BC part is important to look at, but they're really not needed. They don't change the result of the expression. However, when you write A minus B minus C, or A divided by B divided by C, brackets can be important. They can change the result. If you put the brackets on the AB part comparing to the brackets on the BC part, you might change the whole number. So under the special case that no brackets are given, the way that you're supposed to read this is kind of like how we read in regular English. You're supposed to read the leftmost thing first. So if no brackets are given, do the left one first, and then the right one second. So same with division. You really should write the brackets just to clarify these types of scenarios, but just in case you run across a scenario where no brackets are given, you read from left to right.